Okay.
So advanced functions, the other one, which that is like for universities that need above 90%, like in board exams. So if I get above 90%, they'll require that one. So, but
Mm-hmm.
then for calculus and vectors, only the universities that require about 80%. So I'm doing this
Okay.
first because I know I will get about 80% in board exam. So I'm not
Okay.
sure if I'll get about 90. So it's better if I complete calculus and vectors first, and then I go to the other one.
Okay. Okay. Fine. Good. So let us. Yesterday you couldn't join because there was some issue with your timing and my timing of the class. So
Yes,
we
sir.
could not. So today we will have 1.5 hour class. So we can. You can start sharing the slide.
Yes, sir.
I will stop sharing. 1 second.
That disable.
Yes.
Host
Disabled.
disable participant screen sharing shows.
Okay. 1 second. 1 second. Let me check whether I can be anything. Yeah, I enabled it. Allow.
Oh yeah,
1 second.
I got it. No, now it's not.
Why is it not getting enabled? Yeah, now it is enabled.
This one.
Okay, let us move to next slide. Evaluating from graph, evaluating from both sides, and properties of limits. Play the video to watch and take. Next slide. Limit x approaching a plus, a minus. Fine. Next slide. Limit finding the limit x approaching 4 minus 5. Okay, this is like this. It does not exist. Minus 4 minus. Okay, extending towards minus 2 minus. Okay. Okay. Next slide.
Yeah, different.
Same one. Okay.
Yeah,
Next
yeah.
slide. Given a function algebraic, then the limit is defined as follows. Okay. Next slide. Okay. Next slide. Now properties of limits. Which properties you have to do? This one, this one, this one, this one, this one, this one, and this one. R is again assuming limit x tending to f x not equal to 0. R is negative. Okay, fine. So we first discussed till here. How many slides are there?
Uh, yeah, that's it, sir. This is I think it's the last slide.
Oh,
Properties is
fine.
the last 8 slides.
Okay. So let us discuss. It is not so much difficult. It does not need that much of basically limits which is being taught in class 12th or class 11th, it needs a basic understanding of limits.
Yeah.
So if you just see here that in short, I will give you an idea of limit, and then we'll move on to just the parts which are being discussed here. So basically, what is the idea of limit? If fx is equal to x square minus 9, right?
Yeah.
1 second. If it is x square minus 9 by x minus 3. So what we do, we say that it is x minus 3 into x plus 3 by x minus 3, right? This is what we get here. Now, can we cancel x minus 3 from the numerator and from the denominator?
Yes, sir.
Always. When x is equal to 3, that is x minus 3 will be 0. Then it will be 0 into x plus 3 upon 0, which is 0 by 0, which is not defined. So if you have x is equal to 3, you can't cancel x minus 3. So you can say that this is equal to x plus 3 only if x is not equal to 3. If x is becoming equal to 3, then in that case, you can't cancel x minus 3. Do you get this point?
Yes, sir.
Okay, so if you draw this graph, y is equal to x plus 3, this is not same as y is equal to x plus 3, which is the question. So this graph is crossing through when x is 0, y is 3, and then y is 0, x is minus 3. So this graph goes like this. But at x is equal to 3, there is a gap. And then it goes like this. So this is not same as exactly y is equal to x plus 3, which does not have any gap. So there is a slight difference between y is equal to x plus 3 and y is equal to x square minus 9 by x minus 3. So here there is no gap. If are you getting the difference between these two graphs?
Uh, so there's 3 points in this, and there's only 1 point in that. I'm sorry,
Sorry,
x.
Sathya, but
There's only one x in the first graph, and we have 3 x's, I think.
you will get 6 here.
Okay, we have 2.
3 plus 3 is equal to 6.
Okay.
But in here, at 3, you won't get 6. This is a gap. If a road is coming, so by the direction of the road, sometimes you predict the next value. So the limit is actually prediction. What we will approach, not exactly the value, because the value is not defined. At
Okay.
x is equal to 3, fx is not defined. So basically, if you talk here, that f of x is not defined at x is equal to 3. Do you want to write that
Yeah, yes.
above portion? Okay, so just write it.
Sir, can you explain this graph? Like the graphs.
Yeah, I will explain it. So what happened that x square minus 9 by x minus 3 is coming out to be x plus 3 if x is not equal to 3. This is fine now. When we cancel x minus 3 here, we make
Yeah,
sure that x is not equal to 3. So x minus 3 is a straight line. Y is equal to x plus 3 is a straight line. Why it is a straight line? When we plot y is equal to x plus 3, how do we plot it? We just take values of x and y. We take x equal to 0, we get y3. We take y equal to 0, we get x is equal to minus 3. So we see that where it is intersecting the x-axis, it is intersecting minus 3 comma 0, y-axis 0 comma 3. So we draw a straight line. Here also x plus 3, we draw a straight line. But this function and this function has a slight difference, that this is having a gap at x is equal to 3. This is an open circle. It is not defined at x is equal to 3. It is not giving any output. So this is a gap. In the previous one, there is no gap at x equal to 3. So if you talk about f of 3 here, it will be simply 6. But if you talk about f of 3 here, it is not defined. So what actually I mean to say is that fx is equal to x plus 3 and fx is equal to x square minus 9 by x minus 3 are not the same functions. Though it may seem that after simplifying it will give you x plus 3, but it is only if x is not equal to 3. So that a small slight difference is there.
okay.
Are you getting this
Yeah,
point?
now I get it. Yes, sir.
So you can write this.
Yeah, answer.
Okay. So if you now we discuss limit. Now the concept of limit comes that if you talk about this graph and at 3 it is not defined, but if you talk about x is equal to 2.99999, so here it is defined because it is not 3. So the value will be f of x is equal to 5.99999. It is very pretty close to 6, but not 6. If you put one more 9, you put one more 9 here, put one more 9, put one more 9 here. So making x close to 3 is a very minute task. That is exactly you can't say that which value on the left of 3 you should take, which is very close to 3. So that value is being written like this, that x is 3 minus. This is written like this. One second. This is written like this, that it is 3 minus. This simply means that it is very, very, very close to 3 and on the left of 3, but it is not 3. Similarly, if you take x is equal to suppose 3.000001, you'll get fx as 6.00000001. Now you put one more zero, here one more zero, put one more zero, here one more zero. So you can make x very, very close to 3 from the right side also. And still it is not equal to 3, but it is very close to 3. But you can't specify that exact value because someone will come and say, I'm putting one more zero. Still it is not equal to 6, but it is very equal to 3, but it is very close to 3. So these values are written as 3 plus. So if it
Okay.
is given that x is approaching 3 minus, this is called left hand limit, and x is approaching 3 plus, this is called right hand limit. So this is the left hand limit concept and right hand limit concept. And in that situation, we finally write the value of the function equal to the value at the limit, that is, if it is said limit x approaching 3 minus and f of x is x plus 3, limit x approaching 3 minus. So here x is not equal to 3. That is why we have put fx is equal to x plus 3, because it is x approaching 3 minus. So you are still eligible to write fx as x plus 3. If you take x is equal to 3, you can't take fx is equal to x plus 3. That would be wrong. This would be wrong. But if x is 3 minus, you can take fx. Now, you put the value of 3 minus, but you don't know 3 minus. So you will say that you can directly substitute here x is equal to 3 after simplification and write it as 3 plus 3 is equal to 6. So limiting value is the value which it approaches. It is not the exact value. It is the value which approaches. So 6 is the value which it is approaching. So this is the limit value, value of the limit. 6 is the value of the limit.
Okay.
So this is how we get by direct substitution. Similarly here, if it is asked, I will give you to write this. Limit x tending towards 3 plus fx. Same procedure. 3 plus is still the function is defined at 3 plus. So this will be directly substituted and you will get 6. So the left hand limit and the right hand limit in both the situation are coming same. The left hand limit here is coming out to be 6 and the right hand limit is also coming out to be 6. So both are same. So we say that limit exists. When we say limit exists, when left hand limit and right hand limit are same. In some situation, left hand limit and right hand limit are not same. So if in any such situation, if you see that left hand limit is not same as right hand limit, then you will say limit does not exist at that point.
Okay.
Here it is 3. That can be other point there. So you can write this from top to bottom. I'm first scrolling up, then when you write, you will tell me and I will scroll down. From here, na, right?
Oh, yes, sure. So the 3 minus and 3 plus says if it's on the right and the left, right? Like below
Yeah,
3 or 3
yeah.
plus is about point. Okay. Yeah.
Less than 300. But we can't write the exact value because it is so close that we can't specify it.
Yeah.
The difference is very, very small.
Can you scroll down? Yeah, answer.
Okay. So another thing is properties of limit. So the properties of limit are, first of all, that if there is a constant and you want to find the limit x approaching a, this is called x approaching a. Limit x approaching a. So k is a constant. It does not have x in it. So it will not affect the value of k. It will remain k. And if you have limit x approaching ax, then it will be a. That means you will simply substitute a in the place of x. Then third one is then we have uh, if two functions fx additive and you have to find limit x approaching a, then it will be simply f of a plus g of a. Or you can say it like this. We don't know the limit exists or not. So we can say limit x approaching a fx plus limit x approaching a gx. If there is a subtraction sign, suppose it is limit x approaching a fx minus gx is equal to limit x approaching a fx minus limit x approaching a gx. Fifth is fx into gx, where limit x approaching a. So this will be limit x approaching a fx separately into limit x approaching a gx separately, keeping in mind that limits of fx and gx exist at x is equal to a, then only we can apply these properties. If it does not exist, then of course we can't apply these properties, that we separate them. Sixth is limit x approaching a fx by gx. So this will be limit x approaching a fx by limit x approaching a gx.
Sir,
Here one more extra condition is there. Yes,
so what is A? Is it a constant or
it is a
so?
constant. Just as we took 3 there, no?
Yeah,
It can be another constant.
okay.
So limit x approaching a gx and limit x approaching a gx, the denominator one cannot be equal to 0 because in that case, this the ratio cannot be defined. So there is a extra condition here that the denominator is not equal to 0. Then we have seventh property. It says limit x approaching a fx to the power r is equal to limit x approaching a fx to the power r. Now here again, if r is negative, power is negative, then limit x approaching a fx cannot be equal to 0. Why this condition is given? This condition is given because suppose r is -1, simple case. Limit extending to a fx and it is -1. So what a negative power make? It makes the function in the reciprocal. So this will become like this. Now this limit x approaching a fx, this you can't take 0 because if you take it 0, then it will be not defined if denominator is 0. So that is why I'm giving you just an example that if r is negative, if the power is negative, if r is negative, we can't take denominator as 0. Are you getting it?
Yeah,
Further, if r is rational number, like it is p by q, and q is even. If it is odd, then it is no issue. But if it is even, like it is, example, if we take limit x approaching a fx to the power 3 by 2. So this is a square root. And if you take a square root, the value inside the square root should not be negative. It can't be negative because a square root of a negative is not real.
yeah.
So this even is there. Q, which is in the denominator, is even, whether it is square root, fourth root, sixth root, eighth root. But if it is odd, then it is fine. It will give you negative. Cube root is negative. So there it is not issue. So if r is rational number, limit x approaching a fx is greater than equal to 0. So this is another condition. So these two conditions were specifically written in your slide. That is why I'm explaining it here. Now you can write them, and now we will come to the slide. From here, you can write them. From here.
Yes, sir. So, but in this, the first one, if k is a constant,
Mhm.
so what do we put there?
You can't put anything. K is a constant, so X is not there. We can't put X as anything. K will be as K.
Okay. So then what is the difference between the first property and the second property?
There it was X, so you put X as A.
Okay.
In the first one, K remains K. Here,
Oh,
X does not remain X. X becomes
okay.
A.
Okay, yeah.
Should I scroll it down?
Yes, sir. I'm writing the fourth one. You can scroll to the fourth one.
Fourth one, you're writing. Okay. I'm coming in 2 minutes.
Okay, sir. Yeah.
Should I scroll down, Sathya?
Just a minute, sir. I'm writing the sixth one. So is that the sixth one? Is that a comma or should we multiply? Is there a comma?
Six
Yeah,
point.
there. Is it into or
This is comma, comma.
okay, okay,
This comma and in bracket is it is an extra condition other than the condition written on the left.
okay. So can you scroll down? Yeah, that's all.
Okay. So now I'm stopping share here and you can start.
I think this is the last slide.
Yes.
This is the last slide, so that's it. Nothing.
Yeah, we start from the first, from
Yeah.
where the questions have. Let's see theory also, in case we missed any theory.
Okay, yes,
Then we'll
yes.
see questions one by one.
So this is the last one. Where, yeah, yes.
Before this, from the first slide itself.
Yeah, yeah, this is the first one.
No, before. Yeah, this is the second slide. I mean, I think.
So this is the, yeah, this is the technically, yeah, this is
So limit x approaching. Yeah, let us come back to that.
oh, sorry. Yes.
So limit x approaching a plus fx, limit of fx as x approaches the value a from the right. Is this okay?
Yes, sir.
Okay. Limit x approaches a minus fx, limit of fx as x approaches the value of a from the left. Okay.
Yeah,
And limit x approaches a fx exists if the limiting value from the left equals the limiting value from the right, that is the left hand limit, this one is equal to right hand limit, this one. So we don't write plus or minus, we just write a, which means limit is existing.
okay, sir.
So as we took the example there, we can simply say limit x approaching 3 is 6.
Okay,
Even if we say 3 minus, it will be 6, 3 plus it will be 6. So we don't use different terms. So both are 6. So we
yeah,
say limit x approaching 3 is 6. Okay.
okay, yes, sir.
Now we move on to the next slide. Okay. So here in this graph, if you see limit x approaching -4 minus fx does not exist. What it is written does not exist.
Exist.
So x tending towards -4 minus, if you see on the graph, -4 on the x-axis. Do you see -4 on the x-axis?
Yes, sir. Yeah.
and -4 minus. So the minus at the top of -4 means left of -4. So is there any graph left of -4?
No.
So it does not exist.
Okay.
Limit x approaching -2 minus. So just see -2 there
Yes, sir.
and left of -2. What is the output?
I think -3 and -4.
No, no, output. Output is on the y-axis. At slightly less than -2, that is left of -2, slightly. What is the output? What is the value of the function?
It's given to.
It's given 2. So it is 2. Fine. Limit x approach, it will be 2 now. On y-axis, this will giving you 2. Am I moving the cursor? Can you see this? No, you can't see this
No, no,
because my
sir.
share is not. So
Can you see
basically,
mine? My
at
cursor.
-2, the output is 2.
So will they give that, or should we find the
Hmm?
uh, should we find the output?
Yeah, on y-axis. This output is from y-axis.
Sir, so how do we get the output?
Just put your cursor on -2 on the x-axis.
Yeah,
Now move it vertically upward and right, more right. What you are getting on y-axis,
2.
that is the output.
Sir, but then isn't given minus here, so shouldn't we move to the left?
Not that left. It is slightly left to -2, slightly left. Because -2 minus is slightly left to -2. So if you be slightly, that means -2.0000000001. That
Yeah,
won't affect the output. Output will be same.
okay,
Practically, it won't affect the output
okay, yeah,
because the limit is a very small difference, no, between the approaching value and the given value.
okay.
Now 2, 3 plus, what will happen?
3 plus, so
What is the output? No, this is at 3. This is a dark circle, which means at 3, this is the output. If you move slightly right of 3, slightly, even slightly, then this is only at 3. This is a dot. This is enlarged to make you show that this is a dot at 3, which is giving output 1. Because it is at 3 going to infinity. If you see the right wala graph.
yeah. So what isn't that 4?
No, it is not touching the this line. It is actually becoming parallel to this. They have not drawn it correctly. Ideally, this is not touching this line, this y line, that is this x is equal to 3 line. It
Yeah,
is parallel, it is becoming parallel to it. That is why it is infinity given. And
okay,
ideally, this situation sometimes arise.
okay,
So that is why it is infinity. That means it is a very, very large value which cannot be drawn on the graph or cannot be assessed. It is very, very large. So this curve is moving slightly. If you remember tan x graph, have you studied tan x graph?
no,
No, log x also. There are few functions which sometimes become almost parallel to a line. So that meets the line at infinity. That is actually tangent at infinity. So this is actually becoming tangent at infinity.
okay.
Now let us move on to the next slide. X approaching 1 plus fx is 3. So 1 plus slightly right of 1. What is the output? It is 3.
We get 3.
You're getting nothing. Slightly right of 1. Slightly right of 1 if you see on the x-axis. First you move on x-axis slightly right of 1. And
So
then you move vertically upward. Slightly, not this much. Slightly. And then you move vertically upward. So this is not coming as the output. Move upward. Move upward. Now you come to this output. This is 3. Practically it is 3 because you are very, very close to 1. Got it? Yes,
no,
Sathya?
sir. No, I
No.
understand. No.
So you are 1 plus. 1 plus, that is right of 1.
Yeah.
If you take 1 minus, let us take 3 situation here. I will draw, I'm sharing my screen here. I've
Okay.
seen this graph. I'm sharing my screen. So what is happening over here? That as far as I remember, at it was x is equal to 1, na, right?
Yes, sir.
And first we were getting this, then we were getting something like this, then we were getting something like this. It was like this.
Yeah. Yes, sir.
What was the point value here, and what was the
Three,
value here, and what was
three, 3 to 1.
and
Exactly 3 to 1. Yeah.
3 to 1? Okay. So what happens here, that value of the function at 1 is 1. The output is 1. That is the dark circle here. This is the dark circle. Matlab at x is equal to 1, this is included, but this is excluded. This is excluded. This open circle means excluded, and dark circle means included. So x is equal to 1, the value is 1. If you talk about limit x tending towards 1 plus fx, so right of 1, if you talk about, here it is right of 1. So the output would be from this line. And since it is very, very close to 1, it will be almost 3. So practically it will be 3. If you talk about the value
So it can also be 2, right?
at 1 minus, it will be 2. From here, when you will go, you will come to this line. So at limit x tending towards 1 minus, if you approach from the left side, left hand limit, then it will be 2, because from left, the road was coming like this. So the prediction was 2. You can think like this, that there is a road coming and you are a driver, and it is said to you that what will be the next value. So according to the path of the road, since the road is straight, if you are moving from the left, you will say at x is equal to 1, I will land at 2. That is the prediction. That is the limit. That is what limit means. If the car is coming from the right on this road, and someone asks you that at x is equal to 1, what value you will reach? So based on your prediction, based on your path, you will say you will reach 3. But when you will actually reach at x is equal to 1, you are neither reaching 2 nor 3. You are reaching 1. That is the value at 1. But the value at 1 is f1. The prediction is the limiting value. So left hand prediction and right hand prediction are different here. So limit does not exist since these two are unequal. So further you can say that limit does not exist at x is equal to a 1. Getting my point?
Uh,
Any specific question or general question you can ask?
so is there any calculation of finding that? Like the
No calculation, just from graph. From graph you see now. The line is like this. So right hand side, when you move like this, then it will approach 3. From left hand side, when you move 1, you will approach 2. And if you talk about exactly at 1, so both of them are excluded, open circle. So it is 1.
So will the graph be given?
Yeah, graph will be given, of course. Otherwise, you don't know what is the function. Got it?
So how do we find the output?
Output is the y value. Here, this output is 2. Here, this output is 3. Here, this output is 1. 3 different outputs are coming. Here, 1 is coming. Here, 3 is coming. Here, 2 is coming.
Okay.
This is a
Yeah.
function effect, and this is its graph. Like, there is a greatest integer function. Have you heard of greatest integer function?
No, sir.
Okay. So this graph is fine. This graph is okay. We try to understand. We'll see more questions on this slide. First, try to understand it. If you have any doubt, you can ask me.
Sir, I didn't understand this graph thing.
So actually, what is happening, I'm explaining it again. This graph is given to you. This graph is given like this. Graph is like this. This is the value. This graph of the function is given. Okay, in the question. Points are given 1, 1, 2, like this. These all values are given. Now, there are three things asked from you. Limit x tending towards 1, fx, when n1 is being approached from the left. When 1 is approached from the right, it has been asked, and value of the function at 1. So you have to find these outputs. How will you find this output? Just think on your own. I'm not giving you the hint right now. You just think on your own how you will think about it.
So 1 minus, we go to the left.
Hmm.
So shouldn't the left be towards this side, the other side?
Left is there. Here it is left.
That's 1 plus, right, sir?
1 minus, that is left. 1 plus is right.
Okay, so
What will you get? So 1 minus is slightly left off. Slightly. The difference is so minute. In order to show here, I'm showing you the difference, but it will not be shown by a naked eye. It will be microscopically small, like it is 0.0.99999. So it is almost 1. So on the number line, you can't see it by naked eye, but it is different from 1. It is not
yeah.
equal to 1. So if you see the output at this point, won't you get this line which is on the left coming out upward? Other values will not come to your path.
Yeah,
Okay, so the output will be 2,
2.
right? When you come to 1, I'm coming to third one right now. When you come to 1 here, when you see the output exactly at 1, the output is this is 1.
1. Yeah.
So you will say it is 1. When you move further here, so right of 1, it may be a value like this 1.000. This is, but it's not equal to 1. So here, when you see the output, you will see that it is
3.
3. It is almost 3, so you write it as 3. So this is how you are getting it. And
Okay.
since the left hand limit and the right hand limit, these two are not equal, so we'll simply say limit does not exist. At x is equal to 1.
Yeah.
Okay. Done this one.
Yes, sir.
So now we can come to your slide and stop and share.
Yes, sir.
Now let us come to E now.
Okay. So that's -3. So
It
minus
is
3.
not -3 plus or -3 minus.
So
So
it's
you
the
have to
same thing.
calculate -3 plus also and -3 minus also and check whether they are same or not.
Sir,
Both is
so
1.
-3 minus is it -4?
No, no, -3 minus is very, very close to -3. It is minus
Okay.
3.00000001. So what its output is 1. You can say it is 1 practically.
So isn't the if we put in -3 here, somewhere here,
-3 minus.
yeah. So if it goes up, isn't it going to
But
-4?
it is going to -4. No. What is its value? Its value at -3 minus, you are taking with your naked eye, na? If you
Yeah,
see, it is very slightly close to -3. So what will be its output? You are taking this much difference by the naked eye. But if
yeah.
you take it -3.000001, so where does the output will lie? If you put the cursor there at -3, let us put the cursor at -3,
Here.
and then take it slightly left. This is for our naked eye. Otherwise,
Yeah,
we can't see. Now, if you move it vertically upward, what will be the output?
vertically upward. So it'll go up. So it'll
It
be
is
somewhere.
almost 1. It is 1 now, close to, very close to 1. Because at you move closer to -3, you will get 1. As you get more and more close to -3, you will get 1. So it is about closeness. It is about approach. So if you are approaching -3, you are getting 1. Got it?
So it's -3. So -3 minus is here, right?
Mhm,
So when we move up,
mhm.
won't it be touching this line?
Yeah, it is touching this line, but it is very close to -3, na? So the output will be 1. It will not be greater than 1. Now you move it to the right. Now move it to the right.
That's 1.
Very, very close to 1. So
Yeah.
if you move this horizontally close to -3, it will move vertically close to 1.
Yes, sir.
If you keep on moving this horizontally close to -3, that one will vertically move to 1.
Yeah.
Getting my point?
Yes, sir.
Let me again share this, share my screen. What am I saying is, it is like this. This is -3. So -3 minus is here. Now it is giving you an output here. This is 1. Now you move -3 minus towards -3 like this. So won't this output will move towards 1? As it the line is like this, then after some time it will be like this. Then after some time it will be like this. So as you move from -3 minus to -3, the value from here will move towards 1. So the limit is 1.
Yes, sir. Yeah.
Now you can share.
Yeah.
Okay. So -3 minus will give you 1. And what about -3 plus? There only, in E only.
So -3 plus it will be 1.
It will be 1. So
Yeah.
both is 1. So here limit exists. That is why they have written it as only -3. They have not written -3 minus or -3 plus.
Okay.
What about x tending towards -1?
So it's
First take -1 minus. What is -1 minus?
is it uh so
That
there's
is at
nothing.
-1. That is not touching actually. That is as to show us it is exactly at -1. It is 1. On the left of -1, it will cross that. It will not come to that.
Okay. So there's nothing in
No,
-1.
above. Go above. Go above.
Okay, so this is 2.
2. And what is -1 plus?
There's nothing on top.
The bottom.
Oh, that's 1.
So -1 minus is 2 and -1 plus is 1. So left hand limit is 2, right hand limit is 1. So here limit does not exist. They are
Okay.
different.
Okay.
Then given a function in algebraic form, then the limit is defined as follows. That means you just substitute the value at x is equal to a. So that we have just done. Okay. Let us come to the next slide. Here again. Now a part. Can you tell me what will be the output at A? Graph is also given in below.
Yeah. So won't this be root 0?
But it is 2 minus. It will not be exactly 0. Slightly left of 2.
Okay. So
Nothing. Slightly left of 2. That dot is basically to show us. That is why that is the big dot is there. Otherwise, there is
okay.
a point only, slight point. At 2 is it is 0.
Okay. So
Nothing.
there's nothing there.
Why there is nothing? Can you tell me? Like if you take x as left of 2, you are taking, but very close to 2. So can you take x as 1.99? Suppose.
Yeah.
So what is 1.99 minus 2?
0.1.
Minus 0.01.
Okay.
It will be minus.
Okay.
And inside a square root, that can't be negative.
Okay.
So x minus 2 is a negative value. And in a square root, a negative value cannot be taken. When you take x approaching 2 minus, when you take x slightly less than 2.
Okay.
And when x is approaching 2 plus, what would happen? So 2 minus does not exist.
So that will be 0, or that does not exist.
This will be does not exist because it is a square root of negative.
Okay.
It is slightly less than 0, whether it is minus 0.1, minus 0.01, minus 0.00000001, but still it is negative, however small it is. So square root
Yeah.
does not exist.
Yeah. So second one.
0. You can just substitute 2 there because there, as we just studied in the previous slide, that in case of algebraic function, you just substitute the value. So substitute 2 there. 2 minus 2 will be 0.
Okay.
Approaching value is 0. Same value. And what about minus 2?
So that's root -4.
That does not. Again, negative.
So root -4.
It does not exist. No? Square root of a negative value does not exist. Minus 4, it is minus 4.
Okay. Yeah. So 2. So limit of x 2 plus. So does that exist?
Yeah, that is 0. 2 minus
So
2 will
that's
be
2
0.
minus 2 root 0.
Yeah, that will be 0.
So that does not exist, right?
Root 0 is 0.
Okay. So we can write 0.
Yes.
Okay.
2 plus limit 2 plus is existing. 2 minus is not existing.
Okay. So
Are you getting now what we are discussing?
yeah. Yes, sir. That's it. Thank you. Now the properties.
So these properties we have just discussed. These are the same properties. One fourth property is that constant come outside. Rest are all same properties. So these are the same properties which is studied. Now you
Okay.
can do one thing. You can try question from your assignment, and if you will have any problem, we'll discuss in the next class, and we'll start the next topic in the next class, right?
Okay.
What is the next topic? Can you tell me?
Uh, yeah, this is the one we're doing. Next topic is evaluating limits of polynomials, radicals, and rationals.
Okay, okay. I hope we would be able to complete that also in the next class.
Then after that is continuity.
Okay.
That's it. And that's the end
So
of unit 1.
okay. So I think one class for the next topic and one